Okay, very good. Um, Today we got a couple of tasks we got to do. We're going to go over your 1-8 assignment. Okay, make sure you got them correct. Make sure we did correct notations, those type of things. Hit on those type. I didn't post the answers, but I did it on purpose. I know some of us did a lot of it in class, but we'll just check it now. Okay, I'll do that at times. Not that I don't want you to know the answers, but it's just I think it's advantageous for us to go over it in class also. So you guys know that I don't check your homework for correctness. As long as you try it, you'll get your full points. Okay, so as long as you try it, upload it like you're supposed to, you'll get your full points. And then, like I said, sometimes we'll check it in class. And sometimes if we don't have a lot of time or if I know that we're going to cut short, more than likely like next class period, because 111 is a pretty long one. We're doing 9 and 10 today. So we're doing 1.9 and 1.10. You already know them, but we'll just emphasize those. Again, it's more notation than anything else, okay? So we'll go over that. Then we'll do our notes over 9 and 10, worksheet 9 and 10, pretty much rinse, wash, repeat, pretty much everything we do. We do have a quiz, I guess if you want to call it that, learning checkpoint on Wednesday. 1 point, where are we at? 7 through 10. So it'll be 7 through 10. Pretty much a question over the biggest question over each one of those lessons. So basically 4 questions. It's a pretty quick little deal. It's on paper, okay? So remember, quizzes you can retake. Got to get that done if you need it. Hopefully you won't need it, right? But that one being on paper, we don't have an unlimited retakes on that one. So we do have a couple of, I say a couple, maybe only 1 retake. So just kind of keep all that in mind, right? I'm not advantageous on retakes, but I do think there's something to it for a quiz, because that gets you prepared for the exam. But I think in times, an exam, that's when you only get the AP test one time. So that's kind of what we're trying to do, is train you to get prepared for just that one time. And in life, a lot of times you only get that one time, right? You get pulled over speed and you can't say, you know what, I'd like to go back and try this again. No, you're going to get a ticket. So that's where we're at. 1.8, let's look at your answers, or let's look at your worksheet on that one, and let's see if you got what I got. Let me rephrase that. If you got what they got, because I didn't do it. I mean, I did it, but the zeros. X equals -3 and X equals 2. X equals -3 and X equals 2. Whenever you're finding zeros, sometimes you got to look very careful at what they're asking for. Sometimes they'll say, where are the zeros and what are the zeros? That type of thing. This particular time they said, find the zeros. So if you just said X equals -3 and X equals 2, that's okay. I don't think you want -3. I don't think you really want points right there. Just X equals 0 here. That's the 0. X equals 3. We discussed it, that 6 is not a 0, it's a whole. And that's what we're going to be, that's 1.9's lesson, or 10's, one of them. So that's a whole because it cancels. So it doesn't make an asymptote, but it's undefined. So really what it is, I mean, this would be, predict that wasn't there, right? This would just be a linear function, except at 6, it would just have a hole in it. So bless you. Here we go, number 4, -4 and 5. We had to factor both the top and the bottom. Nothing canceled out, so -4 and +5. And then here, +3 was the 0. -3 is not a 0, that's a whole. Again, it cancels top and bottom. Get good at this factoring, please. I beg for you. Zeros are at 0 and 8. And then there's also a hole at -4. You didn't have to tell me the holes, but if you understood that, that got us to today. This next 3, we had graphs. And so this one had a 0 I'm sorry, it wanted to know when it was greater than 0. I'm sorry. So greater than 0 from negative infinity and then negative 1, not including, and then union 0 to infinity. So negative infinity, negative 1, 0 to infinity. We wanted less than or equal to, so not only went it from negative 1 to 1, negative 1 is a parentheses, 1 was a bracket. Again, that's very important that we have parentheses and brackets where they want, right? And then greater than or equal to 0. So we go negative infinity to negative 2, bracket, negative 1 to 0, bracket, 0, parentheses, negative 1, and then 1 to 0, parentheses, parentheses. I think I said 0, 1 to infinity. Too fast, y'all okay? Then we want to know when it's less than 0, and it's from negative 2 to 1, parentheses. Greater than 0 is negative infinity to negative 5, and then also from 3 to infinity. The greater thans or less thans are nice because you know there's never a bracket. It's when we have the equals to that there are bracket situations. Here we could have a bracket situation, but it only goes from negative infinity to 1 without a bracket. Negative infinity to 1 without a bracket. Negative infinity to 0, no brackets. 13, 14. Negative infinity, negative 6, bracket. Negative 2, 1, parentheses, bracket. And then negative infinity, negative 4, bracket. 3 halves, infinity, bracket, parenthesis. So both brackets on that one. Infinity, of course, never has a bracket. Last 4. 16, negative 3, negative 2. 3 to infinity. Negative infinity, negative 8. Negative 2, 5. Parentheses. Parentheses for 18. Negative infinity, 3. 3 infinity. 19, negative infinity, negative 4/3. Bracket 4/3. And then negative 1, 2, bracket on 2. Is that it? Something I need to look at, something you need to see again. 17. You need me to do it or you can see it? Negative infinity, negative 8, and then negative 2 to 5. Anything, anything, anything. Y'all good finding the sign charts? And sign chart, we're going to use sign charts all year long, guys. All year long. And those of you that go on to take calculus, you'll use sign charts a lot. You'll actually end up with like same type thing, values in here. You'll have a sign chart and then you'll have another sign chart. Kind of end up with 2 different sign charts. One of them shows the slope and then one of them shows the concavity. This particular one just shows if you're above or below the x-axis. So that's what this one does for us. Above or below the x-axis. That's as far as we get in pre-cal. And I've had some people actually talk to me about this type of stuff. Remember your kind of your bounces and your crosses, that type stuff. And if you can start putting all that stuff in your heads, I mean, it should almost start making sense. Negative, positive, negative, positive. Like everything's crosses. There's no bounces on these because there's no exponent of 2. Negative, positive, negative, positive. This is just kind of a double check. I'm not saying you should know that, but it's kind of a little double check. Here's an x squared, right? So we end up with a bounce type thing maybe. Positive, negative, negative. So we have a negative, negative because of the x squared. Positive. So if you start seeing a lot of that stuff mathematically, okay, now I can at least somewhat understand what's happening here, right? That's an asymptote at 0. It's an asymptote. And that's what we're talking about today because we know it can't be 0. So it's negative up until the asymptote. Whatever happens, it probably does something, probably just goes down here. Well, then it's also down on this side because it's negative, negative. So it's kind of one of those asymptotes that does this. Right? Anyway, there's a squared, right? So it goes negative, positive, positive. Positive, negative. Positive, negative, positive. Positive, negative, positive. You should somewhat, there's little checks and hints that should somewhat check you. So if you start plugging and chugging and you get something that's a positive, positive, you should probably have a square up there somewhere. And if you don't, then you've chugged and plugged wrong. Chugged and plugged? Plug and chug? That's what I mean by plug and chug, right? When you plug it and chug out a number. That's what I mean by plug and chug. Beautiful. Questions, y'all good? A lot of you guys didn't upload 1-7. I'm thinking because most of you guys finished it in class and you forgot. And over the weekend, you remembered you didn't have anything to do, yada, 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 and then forgot to upload it. Just make sure you get it uploaded. And at the end of the semester, you know, I'm going to give you 2 points because I'm going to demote you. I'm going to give you a demerit for not doing it when you're supposed to because you're making me do more work. But at the end of the semester, if you're missing like a next grade by 1 or 2 points and you got a couple of those 2s instead of 3s, just let me know. Right? I don't want 3 to drop down to a 2 to keep you from getting a B or an A or a C. Y'all kind of make sense on that, right? I don't think 1 point here or there is going to make that big of a deal. If it does, you just remind me at the end of the semester. That's a 325 secret. Okay. Close. I'm done with that bad boy. Y'all done with this? 1-8. I don't want to say it no because I just highlighted. All right, boom. I ask you guys, do I need to go back and post those answers at some point, or y'all okay? I mean, just y'all email me if you need anything, please. Please, like, you know, just that's what you. Hey, I need to see this, or do you have help with this, or something to that effect, right? Please. I'm telling you, I don't have much of a life anymore. I sit at my phone all day and wait for an email to come through. Not really. All right, here we go. 1, 9, 10. 9 and 10. We're going to cover 2 lessons today. Probably could have covered 2 with 7 and 8. In fact, we might do that next year because 11's pretty heavy. 11's heavy. In fact, I think we're doing 11 for 2 days. We're doing 2 lessons a day, and I think we got 11 for 2 days. Then we got 12, then we got 13, and I think we're done. So just kind of always just, I think it's good to somewhat wrap your head around all this stuff and what all we've done. I mean, 13 lessons, we're going to have a test, right? The test is going to cover the entire unit. So it's going to go from 1-1 to 113. It's heavier from 7 to 13 because you've already taken a test over 1-6. But it's heavier. I would say 80-20. But you got to know some of that stuff, of course, in order to do this stuff. So, I mean, that's kind of why we also say that, all right? All right, we know a rational function has 2 polynomials, a numerator and a denominator. So a polynomial up top and a polynomial down bottom, right? Please understand that this g of x is just a constant, like 2. It's not a rational function. I mean, you can make that 1/2. So just because you see a fraction doesn't make it. It's got to have an x down there. You've got to have an x down there. If you have a constant down there, it's not a rational function. Since we're dividing a polynomial by a polynomial, rational functions have restrictions in their domain. We know that we cannot divide by 0, so we must consider any values of x where g of x is equal to 0. We've talked about this. You guys did this in Algebra 2, I know. So we know that g of x cannot be 0 and restrict them from the domain because they cannot be part of the domain. These x values will be the location of either vertical asymptotes or a hole, depending on which one it is, right? Vertical asymptotes and holes both occur when the denominator of a rational function equals 0. I would like vertical asymptotes or holes, but that's okay. So how can we distinguish between the two when working with an equation, right? So a hole occurs when the factor in the denominator cancels out with a factor in the numerator. Here we have a hole. We have an x minus 1 and an x plus 2 and an x minus 1. And we talked about this in 1.8. Because there's an x minus 1 and an x minus 1, then there is a hole at -1. I like to say that there's a hole at a point, because if x equals -1 to me looks like that's a vertical asymptote. So make sure this is going to be key for this class, and you guys, you're going to learn this when you get your test back at some point. When it asks for like where is it at or what is it, those are sometimes two different things. And later on in the notes, they're going to say, give me the x value of where the hole is, or well, that's all you have to give me is the x value, right? Don't actually tell me where it is. Minimum, maximum, right? Sometimes it wants the point, and sometimes it just wants the y value, and sometimes it wants the x value. So you just have to look and see what the question asks. Where is it at? What is the value? That's those type of things. Just be careful about all that. So I like to say that hole is at, and where you find it, you plug -1 back in. Sorry, 1 back in. Plug 1 back into the equation. Well, you can't plug 1 into the equation, because if you plug 1 into the equation, you're going to get 0 over 0. So cancel those out, then plug 1 in. And then when I plug 1 in, I'll get 1 plus 2 is 3. So the hole is at 1, 3. So over 1, up 3, that's where the hole is. So whatever the graph does over here and whatever it does over here, at some point it's going to get to that point, and then from there it's going to keep on going. It's just, if it's linear, then it's just going to jump and be linear. If it's quadratic, it's going to curve, and it probably doesn't curve at that point. It just curves, boom, and it jumps, and then keeps on going. If it's a polynomial, it'll hit there and jump and just keep on going. So 1, 3 is where it's at. This one, this is a x minus 1 and an x minus 1. Now there's 2 of them down here, and there's 3 of them up here, but they still cancel. These 2 cancel. Now I remember a trick that they did one year. Well, we've only done it 2 years. So look at this one. They may do it over there. Oh, they do. Y'all see the difference between those two, right? This one's a 2, this one's a 3. This one has an asymptote. Because 2 of these get 2 of those, there's still 1 left over in the bottom, so there has to be an asymptote. Over here, there's 2 of them here, but there's 3 of them up top. Now it's not an asymptote because there's nothing left on the bottom. Okay, so that's the difference. Make sure you recognize those type of things. I remember that being a little trick for many students. So you just have to look at how many there are. Over here, these are vertical asymptotes because this x minus 1 doesn't cancel with anything. So it's an asymptote. Whereas in this one, there's an x minus 1 and there's an x minus 1, but there's 2 of them. So there's still an extra one. And so because there's an extra one, that gives me an asymptote at 1. Asymptotes should be equations. They should be equations because they're vertical. Go ahead and tell me. Talk to me.
For the g of x equals x minus 1 cubed over 2x minus 1 squared, will that have a slant?
It will. Yeah, but that's just, so the horizontal ones we did in what, 1-7, right? The horizontals and the slants, don't forget all that stuff. So we're all, today it's the holes and the verticals, right? But yes, it does have a slant also. Don't forget about that stuff. At some point, we're putting all this together. My guess would have to be 11 or 12. Here you can see there's a hole at 1. And again, you can just see it. Typically, it's a continuous type function. It's smooth. You don't lift up your pencil except for that hole. Like you don't have any asymptotes or anything else going along. It's not gonna jump, or it's just gonna have a hole. So I say it jump. It's going to jump right over the hole and then continue on. Okay. Whereas this one over here doesn't have one. The graph has a vertical asymptote at 1. Okay. So now we got to look at limit notation. Okay. You guys are getting a little bit comfortable with limit notation. We've always done the end behaviors of limit notation as x goes to negative infinity and x goes to positive infinity. Now look at what our limit notations are starting to look like. Okay. This one says the limit as x approaches 1 from the negative side. As x approaches 1 from the negative side. The limit x approaches 1 from the negative side. Boy, my arrow looks horrible. Okay, That's different than x approaches -1 from the negative side. Okay, so they're going to tell you if it's from the negative side or from the positive side after the number. And so that's a notation that you guys probably have never seen before. And that's, you have to just, it kind of makes sense when you see it, but the first time you see it, it's going to be like hieroglyphics, right? So x approaches 1 from the negative side, and this is as x approaches 1 from the positive side. So you have 1 right here, where that's where the hole is, right? So from the positive side, that basically means you're doing something opposite what you're thinking about. From the positive side, you're kind of reading this graph from this way. And from the negative side, you're coming from the left-hand side. So from the negative side, you're on the left, and from the positive side, you're on the right. I mean, that goes without saying. So the limit as x approaches 1 from the negative side is 3. Like I get really, really, really close to 3. That's where the hole is, the 1, 3. Okay? And these values should be the same, whether you were coming from the positive side or the negative side. Because again, I told you it's somewhat continuous. So those values should be the same. You should approach that same number. Okay? Same thing here. Now this one is an asymptote, right? This one's an asymptote. So as I'm approaching 1 from the negative side, I'm going to negative infinity. As I'm approaching 1 from the positive side, I'm going up to positive infinity. Go away. Why? I don't want you. Okay, so there's the positive and there's the negative, right? So whatever notes you need to kind of see from that, but just kind of understand this is the notation from it. This is the graph from it. You need to know how to read notation. You need to algebraically, I guess, graphically and verbally. All 3 ways in this class. Okay, everybody good? Notes? Beautiful. Here's 3 examples. 3 examples. For each function below, determine the x values. The x values of any holes or vertical asymptotes. The x values. I cheat. I've got a degree in mathematics. How many years old I am, and I've been teaching for 29 years, and there ain't no way I can spell asymptotes. Can't do it. And I can't abbreviate it, because every time I abbreviate it, it makes young adults laugh. So, VA, HA, SA, slant asymptotes. K. Hole. Has that one got a hole at A? Yes, because you got the same thing on top and bottom. And the hole is at x equals -3. Vertical asymptote, x equals 5. Because those go together. Now, I think it's important to know where the hole is. So the hole is at -3. You're plugging in -3, but you can't plug in -3 because you're going to get 0 over 0. So cancel those bad boys out. Then plug in -3. -3 and -2 is -6. -5, I don't know how to do math. -3 and -5 is -8. And -6 over -8 is 3/4. That's what I said. So that gets nothing. Let's fix it all. I'm glad that. First mistake this year, or this week. This year. This was a 5. This is 5/8. Just leave things as fractions. Don't try to change them. You don't have a calculator, just leave them as a fraction. Reduce it if you can. But most of the time, they're not going to ding you for reducing it. Let me rephrase that. Most of the time, they're not going to ding you for not reducing it. If you reduce it wrong, they will ding you. So just be aware of that situation. You should reduce it, though. So that's where the hole is. But they asked for the x, so just make sure you understand what their question is, right? This second one, I got an x plus 1, I got an x plus 1, but there's only one of them up top, there's two of them down at bottom, so that gives me a vertical asymptote at -1 because there's an extra one on bottom. But there's two of these on top and there's only one of those on bottom, so that's going to give me a hole. It will also give me a slant because what's the degree on top? 1, 2, 3. Oh, it has a horizontal asymptote. Yeah, there's 3 x's on top. 1, 2, 3. There's 3 x's on bottom. 1, 2, 3. And so I just need to look at the coefficients. Same on top, same on bottom. Look at the coefficients. And there's a 1, and that's a 1, and that's a 1, and that's a 1, and 1 over 1 is 1, so there's a horizontal asymptote at 1. Oh yeah, we did that already. That's easy. Right. What did we say? X equals what? 2. Okay. X equals 2 is a hole. Just to make sure, let's see where the hole is. Okay, let's see where the hole is. So when I plug in 2, let's see. This is going to cancel this, one of them. And this is going to, I don't guess I care. But this is still going to cancel one of these. You can do that either way because it's going to be the same thing. It's going to reduce. It's easier to cancel at the beginning. So when I plug in 2, I get 2 minus 2, which is 0, and 0 over anything is 0. So not only is that a hole, there's a hole on the x-axis. We also know that 2 will not be a 0, right? Because 2 can't be a 0. It's supposed to be a 0 because of top, right? Remember, the top gives me the zeros. That's what we did in 1.8. But it's not a 0 because there's one on bottom and it can't be a 0. So it gives me a hole. Talk to me. There is not. Because there's a x plus 1 on top and there's 2 of these on bottom. Okay, so because there's 2 of them on bottom, there's an extra one on bottom. Because it's extra, that gives me the asymptote. If they cancel evenly, it'd be a hole. Great question. Everybody else okay with that, right? If there's an even number of these, if it's x plus 1 squared and x plus 1 squared, then that puts the hole there. G of x, better factor. I could have made that x squared minus 4, but that's x squared plus 4. And you'll see this often too. You probably didn't see it a whole lot in Algebra 2, but they like to do this, meaning x squared plus 4 will never be 0. So if I just gave you, let me turn colors or something, right? All this stuff's notes, so I can write whatever I want. This will never be 0 because they're imaginaries, right? If I move the 4 over here and take the square root, I got a -4, and then you got plus or minus 2i, and those don't exist because they're imaginary. So this will never have a vertical asymptote. It will never have a 0. It has a horizontal asymptote because the degree on bottom is bigger. So these graphs end up looking something like this. Something I don't know for a fact, but something like that. Like they don't have any holes, they don't have any asymptotes, but they do have a horizontal asymptote. But there is what? In this particular one, this one over here, there's a 0 or a vertical asymptote or a hole. Has to be a vertical asymptote because there's no x's on top, nothing cancels. And so this has to be a vertical asymptote. X equals 0. And I don't have to worry about that part of it. I'll check with my, so we have, at the end of the year, when you guys take the AP test, they scan all your AP tests. That's why they tell you don't write outside the box. because they scan them and they put them in a computer. And then teachers from all over the United States go somewhere, Kansas City, for AP Pre-Cal to grade these tests, your tests. And so, well, Miss Mims is one of those that goes and grades. And so I ask her a lot of times, what do they see on that test, just to make sure that what you guys put, they're getting full credit. I don't know if that's technically okay to write. I don't know what they would do on a, I think most of this is multiple choice questions, period. I told you we know the free response questions. You've already seen a couple. Write a left and right statement, limit statement. Is this it? No, I got a couple more. Okay. Write a left and right limit statement as x approaches 2 for each of the functions. So this is where you're going to get your non-hieroglyphics, unlike me. And you're going to try to write this as pretty as you can. You're going to write LIM. And you're going to put right underneath that x approaches 2, because that's what it says. And the left would have to be from the negative side. And then you'll see them do one of two things right here. They'll either put f of x or they'll put the whole function. I think it's just as easy to put f of x. If you have to know what f of x is, it's right there. F of x equals this. Okay? And then I'm going to go ahead and write this one down here. The limit as x approaches 2 from the positive side of f of x. And so now you got to just start thinking to yourself, okay, positive 2. Positive 2 for this particular function is an asymptote because it doesn't cancel out. So I'm either going from this side, I'm either going to negative infinity or I'm going to positive infinity. I'm doing one of the two. And then on the other side of it, I'm either going to negative infinity or I'm going to positive infinity. And we just got to plug and chug to try to somewhat figure that out. Okay? So I might plug in from the negative side of 2. From the negative side of 2, maybe? How about I do it like this? How about this? Negative 3 and 1. Y'all see what I did? I found all the zeros kind of like we did in 1.8. I want to make sure that when I'm on the other side of negative 2, of 2, I don't want to plug something in like negative 200, right? Even though that's to the left, that's on the, I just want to just to the other side of negative 2. Well, I would like to plug in 1. I keep saying negative 2 from the negative side. I'd like to plug in 1, but that's going to give me 0. So I just kind of like plug in 1.5. Okay? You don't care what the value is. You're just looking to see if it's positive or negative. So 1.5. 1.5 is going to make that positive. 1.5 is going to make that positive, and 1.5 is going to make that negative. Right? And so I'm at the negative side. I think I'm headed to negative infinity. Okay? And then on the other side of 2, which is 3, 3 minus 1 is positive, 3 plus 3 is positive, 3, that's positive, I probably am headed to infinity. Y'all okay with that? Y'all do have, for homeworks, right, if I don't post answers, you have calculators. You can punch that in your y equals and hit enter, and you can see what this thing does. And then you almost don't have to guess. This is on your test. That's a non-calculator question. You can't check. Homework, you can check. Here we go again. Let's change color. Limit x goes to 2, negative side, g of x limit x approaches to positive side, g of x, limit x approaches to negative side, h of x, limit x approaches to positive side, h x. This one's a whole. When it's a whole, I'll just cancel those two things out and plug in 2. And when I plug in 2, I get 2 plus 4, which is 6. And I'll get 2 minus 3, which is negative 1. And that gives me negative 6. And so the whole is at 2, negative 6. Those are a little bit easier because it's approaching the same thing from both sides. It has to approach the same thing from both sides. Go ahead and cancel if you can cancel. This one's going to give me an asymptote. Asymptote. 1, 2, 4. 2 from the negative side. 1. I'd like to plug in 1, but I can't. So I got to do 1.5 again. You're good with all that, right? 1.5 is going to make that negative. 1.5 is going to make that negative. 1.5 is going to make that positive. Negative, negative, positive. Is that right? Did I do that right? Positive. Yay? Good math there? Nobody's saying anything. And then positive side from 2, that's 3. Negative, positive, positive, negative. Yay? Good? I'm getting better right now. I don't know if you're... I can't make a sideways 8 very well. Turn your paper sideways and write an 8 if you have to. I just do the 2 circles. But that's the way I make my 8s too. What else we got? Write an equation. So there's 28 of you cats in here. There might be 28 answers right here, and they'll all be right because they don't care what it has. You just got to, there's right parts. So the limit as I'm approaching 3 from the negative side and the limit as I'm approaching 3 from the positive side is 5. That must mean what? There's a hole at 3, 5. Right? There's a hole at 3, 5. 3, 5. So there's a hole at 3. They want me to do f of x. Uh-oh, got to turn that to a pencil to write. So f of x, write an equation. Equation. So guys, this is clutch. Make sure if it says equation, you got something equals. Okay? Because if you don't write f of x equals for an equation, you're going to get it wrong. Okay? You're going to get it wrong. No matter what you got. F of x equals. All right, so I'm going to have to put me a little parentheses, and I got 3. 3. So x minus 3, x minus 3. That's going to give me the whole at 3. I just, when I get done, I got to make sure it's at 3, 5. Or, yes, 3, 5. And then also I'm going to negative infinity, positive infinity at 1. And so that means at 1, I better have an x minus the 1 down here. Okay, so that's going to give me this, that's going to give me this, and it's going to give me a hole, but I don't think the hole is going to be at 5, right? Because if I plug in, now, let's see, that's not going to give me 5, so let's see, yeah, because I'm going to get a hole at, what? 2 over, no, that cancels. 1 over 5 thirds, 5, 1, 3 minus, that's 1/2 is where the hole is right now. I don't want it at 1/2, I want it at 6. So, oh, I want it at 5. I want it at 5. X what? X minus 10. That's going to give me a 0 at what? 10. Is that okay? As long as I fit those descriptions, I'm okay. Now plug in 3. Plug in 3. 3 minus 5. 3 minus 10 is negative. Huh? Oh, it's got a 13, huh? Y'all see what we're going? Y'all see kind of where we're going on this, right? If I plug in 3, 3 minus 10 is negative 7. Oh, yuck, that's already bad, right? So now you don't like the 10, you like what? Oh, okay, you want to put y'all understand there's 1,000 things I can write right here. Whatever you got to do to get it to be 10. Y'all okay? No? I've seen some confused looks. Okay. When I plug in 3, I have got to get out a 5. When I plug in 3, I've got to get out a 5. Well, I already got this canceled, right? So I'm getting 3 minus 1 down here, which is 2. So I got 2 down here. So this needs to be a 10 up here when I plug in a 3. So x minus whatever plus, we decided, right? That needs to be 10. Well, x is 3, right? X is 3. So if I move the 3 over there, this has got to be 7. And now I shouldn't cross those things out because it's got to be part of the equation. This is probably what the easiest way you can write this, but there are many other ways you can write this. So your function is x minus 3, x plus 7, x minus 3, x minus 1. Now I know I have a hole at 3, which is what it told me to do. I know I go to negative infinity. Oh, do I know if I go to negative infinity? Let's plug in what? 1 on the 0. If I plug in 0, that's negative. That's positive. That's, no, this cancels. So that's positive, that's negative, and that's negative. I'm okay. Y'all okay with what I'm saying? Right? I plugged in 0 because that's from the negative side. I should be at negative. If I'm not, I'm just going to throw a negative somewhere. I just throw a negative on top or bottom. I shouldn't have that equals 5. Good? One more. I got a hole at negative 2, 4. This is f of x again. So x plus 2. X plus 2. That gives me the hole. And then I got an asymptote at negative 1. X plus 1. All right, so now I got the holes, I got the asymptotes. Go ahead. If what now? Go ahead and say it again. Yes, if it was wrong, but because it's not wrong, that's why it worked, right? My guess is if you did the negative, it would have been a negative 5. Because I don't think you can get there because the asymptote. Sorry, we had our own little conversation up here. Everybody okay? He was asking if I just threw in a negative because that was a positive 0, then I wouldn't get the negative, I wouldn't get a positive 5, which is true. But because of the asymptote, it's impossible to give me an equation that does that. If that kind of makes sense. Here we go. We're okay with this part? I hope we all can get this part. Now we got the hard part. We got to try to make sure we're getting to 4. Right? We got to make sure we get to 4 when I plug in negative 2. And of course, when I plug in negative 2, that's 0 over 0. When I plug in negative 2 right here, I got negative 2 plus 1, which is negative 1. So if this is negative 1, I need this up here to be a negative 4. And so if I want that to be a negative 4, when I plug in a negative 2, then that will give me a negative 4. Yeah, I don't know. Hit me. Go ahead. If I plug in negative 2, right, I'm going to get z, but it's 0 over 0. So I cancel that part out. Right? Okay, I need it to be 4. When I plugged in negative 2, I got negative 2 plus 1, which is negative 1. I need it to be 4, so I got negative 1 on bottom. I need it to be 4. Well, the only way for that to be 4 is this has to be a negative 4. And the only way for that to be a negative 4 is if I do minus 2. Okay? And there are other answers. That's not the only answer. That's probably the simplest. Make sure I'm going to infinities. I want to go to infinity, infinity. Uh-oh. I'm not going to infinity, infinity, am I? If I plug in a negative, what? Negative 1 from the other side, negative 1, negative 2. I can't plug in negative 2. Negative 3. No, I can't plug in negative 2.5. Negative 2.5, that's negative. Negative 2.5, that's negative. Those cancel anyway. Negative 2.5, that's negative, that's negative. Everything's, we're okay there. Now I need negative 1 on the positive side. So 0. Negative, negative. I'm not getting there. Y'all follow what I'm saying, right? Let's probably need one of these to be a squared bounty. Is that going to mess up anything? It doesn't mess up my asymptotes. It doesn't mess up my zeros. Now what's that on the bottom? When I plug in negative 2 plus 1 is negative 1, but now it's negative 1 squared. That's positive 1. So now I need that to be a positive 4. If I need that to be a positive 4 when I plug in a negative 2, I need that to be a 6. Y'all see what I did on that? There, you guys are probably smart. You know, ain't no probably to it. Y'all are smarter than me on all this stuff. I just think it's, I don't know, better just to think about all this stuff and kind of just walk through it. Kind of trial and error type things, almost like my factoring. Just keep trying until I get something that makes it work, rather than try to figure out a certain way that makes it work that may not work the next time. Beautiful. What do they want me to do here in the last ones? Sketch a graph, is that it? That's all I got left? That might be easier. X has a hole at 1. Sketch a picture. Again, 28 of us in here, we could all have 28 different answers. Sketch a picture. It has a hole at 1. As X approaches 4 from the left, it increases without bound. That must mean that 4, I have an asymptote. And I'm increasing without bound. As X approaches 4 from the right, it decreases without bound. Has a hole at 1. It didn't tell me where at 1. It just tells me at 1. Uh-oh. I messed up. I don't like that. One, because it increases without bound. So I'm going to put a hole right there. If I'm going to put a hole right there, whoops, I did messed up again. Undo. Can I undo? I think I can erase. Go. There I go. There. And it increases without bound. I'm putting an asymptote at -1. Put an asymptote at -1. Except I put a hole there. Oh, yeah, I see some confused looks. No, okay. Yeah. Confused look. No. Eh. Eh. I think you almost have to have a horizontal asymptote to help yourself out on that. And I don't want it on the x-axis because that won't give me a hole. That gives me an asymptote. So I just made it below it. If it was the flip-flops, I'd make it above it. Turn colors. Green. Has holes at -2, 3. And x approaches -1 from the left. It decreases without, so -1 has to be an asymptote. As x approaches -1 from the left, it decreases without bound and it decreases without bound. I think this one's a lot easier. So I'm going to put a hole right here at 3 and at -2. Good enough. Yep. No. Like I said, there's 28 of us. It can be anywhere. I don't think, I'd really be surprised if the holes would be symmetric. But, yep. Sure. You don't need to ask that. We're in high school. Maybe. Gets a little harder a little bit. Some of those are a little harder. That's the price you pay for signing up for this class. You get practice. You got homeworks. We'll see how it goes. We'll fix anything on Wednesday.